Okay, so for this lecture, we will continue our discussion about hypothesis testing. So in the last lecture, I introduced to you the so-called Z-test. Now, let's have a formal definition for for that statistical test. So here we have a definition. So the Z-test for a mean mu is a statistical test for a population mean. The test statistic is the sample mean x bar. So the standardized test statistic is, so we have the formula z equal to x bar minus mu all over sigma over square root of n. So when these conditions are met. So first one, so the sample is random and at least one of the following is true. So the population is normally distributed, or the number of samples must be greater than or equal to 30. So take note that the formula here is applicable when sigma is known. There are some cases that sigma is unknown, but they are using z-test. There's a theory behind that, but for this lecture, maybe we can focus if sigma is known, we can use the z-test. I'll introduce to you another test if sigma is unknown. But for this lecture, we will focus on this condition. Okay, so let us take this example. So according to a study, the mean cost of bariatric weight loss surgery is $21,500. You think this information is incorrect. You randomly select 25 bariatric surgery patients and find that the mean cost for their surgeries is $20,695. From past studies, the population starvation is known to be $2,250 and the population is normally distributed. So is there enough evidence to support your claim at alpha equal to 0.05? Okay, so we will answer the given example using software Megastat. So let us first analyze the problem. So the claim was the mean cost of bariatric weight loss surgery is $21,500. So let us write it here. So we type mean cost is 21,500. And then for HO, so what will be our HO and HA? So here the claim is an equality statement. So the mean is $21,500. So that means we write it here in HO. So mean cost is $21,500. Now for HA, since the mean is equal to $21,500, so its complement would be not equal. So we type mean cost is not equal to $21,500. And then for our level of significance, so we are given 0.05. And then for statistical test, so let us first analyze the given problem. So it says here that the population standard deviation is known and the population is normally distributed. So by that, we can use the z-test. So we write it here, so z-test. And then for p-value, let's look at megastat. So we write here mean, SD, and N. So the number of samples is 25. Standard deviation. So here we will use the population standard deviation. SD would be 2,250, and then the mean, so we are looking at the sample mean, that is 20,695. Okay, so we can now use megastat. So we click megastat, hypothesis tests, mean versus hypothesized value. We click input range and then drag the necessary information. For the hypothesized mean, we have 21,500. And then for the alternative, we put not equal. For this section, we click z-test. And for the confidence interval, so let's subtract 0.05 to 1, so that would be 0.95 or 95%. So let us now click OK, and we click yes. So here's the result. So notice that this value has no color. That means our decision would be fail to reject the null hypothesis. So we write here 0.0736 for our decision fail to reject HO. And then for the conclusion, so if we are failing to reject HO, we are in favor in HO. So our claim is at HO. So we may say that there is a sufficient evidence to support the claim. So for the second statistical test, for the parameter mu, take note we are only at one sample. So for testing mu, if sigma is unknown, we have the so-called T-test. So the T-test for a mean mu is a statistical test for a population mean. The test statistic is the sample mean x bar. The standardized test statistic is given by this formula. So take note, if sigma is unknown, we can use the sample standard deviation to estimate the population standard deviation. And then these are the conditions that to be met. So the first one, the sample is random and at least one of the following is true. The population is normally distributed, or the number of samples must be greater than or equal to 30. But some books, they use T-test if the sigma is unknown or the number of samples is less than 30. So for example, a used car dealer says that the mean price of a 2-year-old sedan in a good condition is at least $20,500. You suspect this claim is incorrect and find that a random sample of 14 similar vehicles has a mean price of $19,850 and a standard deviation of $1,084. Is there enough evidence to reject the dealer's claim at alpha equal to 0.05? Assume the population is normally distributed. Okay, so we will use again a software to analyze the given problem. So let us first write the claim. So the claim was the mean price of a 2-year-old sedan in a good condition is at least $20,500. So at least meaning it is greater than or equal to $20,500. So let us write the claim. So mean is at least $20,500. Now, where can we put this claim? So I told you earlier that at least meaning that is greater than or equal. So this statement will be put it in HO. So let us write mean is at, let's write greater than or equal to $20,500. What about HA? So if our HO is greater than or equal, our HA would be less than. So we write mean is less than $20,500. For the level of significance, we have 0.05 for the statistical test. So let us first analyze the given problem. So there is no value in the population standard deviation, and there is only a sample standard deviation, So that means we can use the Ttest. Okay, so take note of this. The random sample was less than 30. So by that, you have to use Ttest. So we write it here, Ttest. And then for the p-value, we will use megastat. So for the mean, we have 19,850. Star deviation 1,084. And then for the number of samples, we have 14. So we click megastat, hypothesis tests, mean versus hypothesis value. We click input range, drag the necessary information. For the hypothesized mean, we write 20,500. And then for the alternative, that is less than. So the test statistic is Ttest. And for the confidence interval, we have 95%. And then you click yes. So notice that there is a color in the p-value. Let us first write the p-value here. That is 0.0215. So for the decision, since it has a color, we have reject. HO. Now, for the conclusion, since we reject HO, we are in favor of HA. So that means that there is a sufficient evidence to reject the claim.